So in this video, I want to show you guys this one solubility product related ionic equilibrium question that involves concepts from uh, coordination chemistry. It's concept heavy, so let's get into problem solving. So let's just, damn, that's a lot of wobbly. Wibbly wobbly, wibbly wobbly. Oh ho ho. Okay, so let's get into problem solving, right? Uh, so what the question is that Zn zinc hydroxide is a sparingly soluble salt, and it kind of dissociates into Zn2 plus and two hydroxide ions. It's sparingly soluble, so it has a pretty small KSP. So this is given to you, and let's say that this is your solution where you have dissolved this. And what you do is you take like a huge beaker of 1 molar ammonia solution and you dissolve it. And I've used the word large beaker because the volume should be big enough for you to be able to neglect the extra volume added by this solution to ensure that the concentrations kind of remain the same. So once you do that, complexation reaction begins, and your Zn2 plus ions that were there in the presence of, I drew off the large arrow, so they react with 4 ammonium molecules to create a complex. So this is the complex you get, and complexation reactions are quite favorable. So let's say that the complex formation equilibrium for this is 3 into 10 power 9. So now we want to find the equilibrium solubilities of zinc hydroxide. So what we're gonna do is initially what I was thinking is to write this as S, 2S, and write this as S minus X, 4X, X. But I was getting a headache by solving like eliminating X and plugging it into this. I found it very tedious. So there's another method, and it's something like this. You solve from here and go back to this. So how you do that is, what you have to understand is, up until this S and 2S, it's all fine actually. So let's assume 2S of hydroxide is formed, meaning S of Zn is formed. But now what happens to this S amount of Zn that's formed is that some of it remains as it is, as Zn2 plus. But some of it gets complexed. So essentially, you want to find this S, right? The question says find solubility. So you want to find S. So let's just break the question into finding Zn2 plus concentration and the complex concentration. And you add both of them, you get S. So basically, in order to do that, let's start out with the complexation reaction first. So we know that For complex formation, your Kf, which is equal to 3 into 10 power 9, is equal to ZnNH3 4 by Zn concentration, Zn2 plus concentration, and ammonia concentration. I mean, power 4. But since we have taken a 1 molar solution of ammonia, it's like in large excess, its concentration is rarely gonna change. So we can just assume it to be 1. So now what we have is Kf into Zn2 plus is equal to ZnNH3 2 plus. So this is what you have. And the cool thing is, what we know is, this S is comprised of Zn2 plus and complex. So I can say that by adding Zn2 plus concentration and your ZnNH3 complex concentration, I'm gonna get S. So I'll just put this into this, and what I get is Zn2 plus Kf into Zn2 plus equals S, and I'll just take this common into 1 plus Kf equals S. But see, Kf is in the order of 9, so adding 1 is not gonna do any difference. So might as well write it as Zn2 plus into Kf equals S. So this is one of our important relations. And further, what I can write is Zn2 plus concentration is equal to S upon Kf. And we will plug this into your KSP equation. So now what you know is we know that KSP is equivalent to Zn2 plus concentration into OH minus concentration squared, right? So we can plug this as Zn2 plus is S by Kf, and initially we took OH concentration as 2S, so this is gonna be 4S squared. So what you have is 4S cubed by Kf equals KSP. And now this is super easy to solve. You have everything. So 3 into 10 power minus 17 into 3 into 10 power 9 is equal to 4S cubed. 3 into 10 power, I don't know, minus 8 equals 4S cubed. And you can go ahead and solve this. So if I had to solve it, I would do it something like this. So let's just multiply by 10 and divide by 10. So what you have is 7.5 into 10 power minus 9 is equal to S cubed, or S cubed is equal to square root of this is approximately like, I don't know, 1.9 or something. 1.9 into 10 power minus 3. So that's your S value. Like, so essentially the gravity of this result is actually that this is a huge number. You might not realize this, but this is actually huge. You might be like, how it's in orders 10 power minus 3. But let's consider the fact that if there was no complexation reaction and this were the only case, if you were to solve the solubility product from this, you would get 4s cubed equals 3 into 10 power minus 17, or s cubed equals 7.5 into 10 power minus 18, which is 1.9 into 10 power minus 6. So if you see the answer, the solubility has increased like 1,000 times. So this just goes to show that because by adding ammonia basically attacked your Zn2 plus concentrations, and by reducing your Zn2 plus concentration, it pushes the equilibrium in forward direction by 1,000 times. So hence increasing the solubility.